Welcome back. Second half of the year, IED. Let's keep going. We're going to, I'm going to show you in this tutorial how to put together a drawing and talk a little bit about some of the different things that are in a drawing, some of the different elements about the drawing. I'll have you create one of your handlebars, and it's already shared with me, so I'll be able to grade that when you create that as a project. So we log into Onshape and find your handlebars that you've shared with me. So back when you guys, if I scroll down, I'll see all of your handlebars. And so you can go and open that file up, please. If you did not create handlebars, then I will put a file that you can use in the Google Classroom, and you can open up those and create a drawing from those. I'm going to go back into, I was using Mr. Penn's here as an example earlier, so I'll just keep doing that. And I had already created a little test drawing before making this video for you guys, practicing some of the elements I'd like to show you, putting in different projected views, an isometric view, putting a detail, putting a section view, using dimension tool here. So let's do it. Let's show you how to do it. Okay, so if I'm back here, down here on the tab, the Part Studios side, again, this here will highlight the full 3D geometry of the handlebar. I can right click on it down here and actually rename these different bodies in the model. So this one we'll just call the actual handlebar body. That's the 3D geometry that really makes up the body. And handle bar, is it what? Call that one word, I think so. There we go. Enter. Actually, so what I'll have you do is just go right into a drawing, okay? So you're gonna hit this little plus symbol and it will allow us to create a drawing. And I had to go search for this using this blue show Onshape drawing templates. These are different sizes of templates, basically different drawing sizes. Oftentimes in industry, you like to print a really big, like blueprint, and drawings can be big and can be various different sizes. So that's what these different sizes here are. And there's different formats as well, these ANSI formats versus ISO formats. This has a lot to do with what I'll show you when we get into creating the drawing. But we can just pick a basic ANSI A size millimeter, not inch drawing, because we created this in millimeter. It makes sense to make a drawing in millimeters as well. So it comes up with this title block for you. I want to walk around and show you what's in that title block. But before we even do that, it automatically thinks, because I open it up from the part, that I want to make a drawing of the handlebar, and I do. So I click on it, and then I'll drag over here to drop the first view. So I'll drop this rear, I'll call that a rear view of my handlebar. And then if you keep dropping, you can drop other views. So here's a right side view. And if it'll do those two views like that. But you can put in other auxiliary views. And I'm going to kind of walk through what all of these things are up here as well when we're doing this. But I can put another projected view. So just like with how I showed you guys using projected lines, you can create projected views. And so if I create projected view, I click on that one and drag down, I can create another. Here's a bottom view, and maybe I can even up here create a top view. Most engineering drawings would be standard when they're simple parts. The 3-view or 4-view drawings are fine. When you get to more complicated parts, oftentimes you have more views with more dimensions and more information on them. I can also put in an auxiliary view, which would be more like an isometric view. Or I could just hit this thing and say insert part or insert view. And then under view orientation here, I can choose isometric. That's that 3/4 view. A lot of times you'll see that on a sheet. I might make it a little bit bigger, which is another uh, trait that you might see on a drawing oftentimes. There. And any one of these views I can readjust it. And it's important in a drawing to have nice um, balance to the drawing. I know I've had a lot of bosses over the years that have a lot of strong opinions about how to properly balance a drawing. Okay. So something like this might be really good for us to start with. And I will show you how to add other elements into this. Okay. But I'm going to zoom in really quick and talk about what are the default settings for this ANSI millimeter type drawing. And it's basically given a declaration to everybody that, all right, an otherwise specified dimensions are in millimeters and angles are in plus and minus degrees. Surface finish looks like this. That can talk about, do we paint it or what type of finish what the surface has. Break all sharp edges and remove burrs. So you imagine we're making these out of metal tubing in our process. We bend the metal, we cut and bend the metal, and it's just a standard thing that you don't want anything dangerous on a part that a lot of people are going to be touching and handling in the manufacturing process. All right, so it dumped my name in there because I'm logged in and I created it. It put the date on there. Checked would usually be like your manager, and approved could be the boss. And you could even have a couple more spots for the boss's boss and the guy who pays all the bills. So it just depends on an organization. We can talk about what the material type it is, what finish type it is, and it just said this is the drawing size. The drawing number would usually be the part number. So we create a part number for the company, and the revisions levels usually go like A, B, C. Every time you make a change, you revision it up. Talks about what scale that is again. So that scale is 1/6 scale, means that the drawing piece here is 6 times smaller than the actual handlebar. I want to talk about the weight really quick. You can actually get the weight automatically by going back to the part. And in this case, I'm going to right click on this body down here, and I am going to assign material. Now, I already did this because I knew I wanted to make my handlebar out of chromoly steel, which is a high strength light steel used in a lot of racing and bicycle applications. You could also make this out of all kinds of high strength aluminums. And in fact, I think they mostly do make these handlebars out of high strength aluminums and make them nice and light and tough. Same with like aircraft and a lot of other um, light, strong applications. Okay. But 41 steel is a type of steel called chromoly. In fact, all I did is Google it over here, 4130 steel tubing. I got this really great sheet that gave me all this information about the tubing, how it's made. It talks about the cold drawn and seamless process, and gives you the chemical formula here, which I think was really interesting, and it got me to really search on molybdenum, which is a real small additive in the steel mix. But this is pretty fascinating element. And he talks about how it's even essential element for life and our type of organisms. Eukaryote, right? Isn't that how I pronounce that? And by the way, just to come, this is a huge mine in Utah where we get a lot of copper, gold, and molybdenum and other elements. Look at the size of this. This is how they get most of the elements nowadays in industries. Those are those giant bucket trucks that are like 3, 4 stories tall. So I think those are regular size trucks right there that you're seeing. So isn't this incredible? This is how they mine nowadays. And this was a really good Wikipedia article about this giant mine, Bingham Canyon mine. I used to work in the mining industry. This is one of the largest mines in the world, and it's certainly the most lucrative one, I think, in America. Gives you another view. There you go. They just kind of removed a mountaintop there in Utah. It's pretty incredible. I know some of us are going to be like, "Oh my God," but Remember, the West is full of mountains like this for thousands and thousands of miles. So, changing the landscape for a few for necessary elements, as long as I think it's done in a responsible way, um, it's it's reasonable. It's not exactly a huge part of the geology. And most you have to realize out west in America, there lives very few people. Look at the size of these counties. You'll have people who, nobody who lives out there. Pretty interesting. So um, I'm going to include this video as part of the lesson. We'll talk about stress strain and the strength of materials, but I'm going to go back further right now to this model. So in the library, all I did is type in steel 4130 is the technical definition. I selected it. And by the way, now you can come down here and get the mass for the part. If I highlight it here, there it is, 0.709 pounds. And so I'm going to go back to my drawing here and zoom in down here. And for example, type that in. So I'd ask that you guys make your also 4130 steel and then measure its weight for me, please. If it doesn't match, don't freak out. It's okay. I know some of us didn't make the model perfectly. I just want you to give that a try, okay? Okay, so at the top, let's talk about all this stuff at the top really briefly. So we can do a section view and auxiliary or detail view. These are cool features when you want to zoom in on an area or cut apart in half and measure how it looks in the interior. So I'll do a quick example of that, and then we'll move on over here to the dimensions and sketch elements. So for example, if I wanted to zoom in and look at this part, I'm just going to click on this and it's going to put a circle on that, okay? It will allow me then to go ahead and drop a detail over here. Another thing you can do on a drawing, which is interesting, is you can right click and you get some different options here of what you can do to views. And for example, I think it's, you can show the shaded view. You can actually make it shaded just like it is over on the part side. And it will talk about the scale, how much it scaled it up. It'll talk about here's the detail view A. By the way, I can move that A out so you can see it better like that. And typically what you would see is oftentimes the isometric view where you can see the whole part in all different angles. Oftentimes that one it will be shaded. So I'll do that over here. And over here, I'm going to zoom into this one and show you a couple of tricks of dimensioning next. But what I'll do is hide the shaded view there. Okay, so that's tricks that you can do to really jazz up a drawing with good information that the viewer would need. Pull this one up more. There we go. Now, dimension. That's the next big tool because that's the most important thing for many of these drawings is you're really adding the dimensions. Now, when we made this, we really built the centerline sketch and then extruded the tube. So in the process of making this tube, you might bend it to the inside instead of the outside, but most of the time they're going to design to that center line. And so for example, watch this. But here in this segment over here, we can add centerline elements that aren't shown. So watch, if I select this one and this one, and then click the inside and outside, it will show me that center line of that sketch that we built before we actually we did a sweep, right, for this. We swept that here using this tool along that sketch, okay? I'm gonna escape. That one's a little too long. It goes, nothing should ever go off the page of the drawing. Okay, so now watch, dimension. It's important to see this tab will show you specific ways to measure stuff and get different measurements. But just using the dimension tool itself is usually enough. So if I wanted to know the radius that we put, remember how we put in a 40 millimeter uh, radius on that curve, and if you drop dimension, you can change certain things about it. We're going to really start to explore this most important of the elements. This one just tells you is it a radius or a diameter. And I could change that to diameter. Here's the actual measurement value, and here's the tolerance. And this is where I want to talk about the paperclip I had you guys bend. So it's important to know that you will not always make a perfect part every time. What the engineer is doing here is saying, is it allowed to vary by plus or minus 1.5 millimeters? That's the case here, and that's pretty normal. I find that's a pretty good guess. This software made a pretty good guess at machine tolerances. That would be for a machine cutting this and making it, and you may be able to hold that type of a tolerance. You can change your units or whatnot here, and you can put more information here in this blank cell, and then there's other information. You can make it a reference dimension, or you can make it a dimension that must be measured every time you make the part. That's what this would indicate. This would mean reference, meaning it's not a driven dimension. It's just there for the viewer to see what it is. I can toggle between diameter, that's that symbol, and radius, okay? So a lot of stuff you can do when you dimension stuff like that. Again, let me show you another quick example, and I'll have you guys ask you guys to add these center line sketch elements here, because it might be really important for the viewer of the drawing to know that, right? How many millimeters total distance between those two bends? What else might be another really important dimension to know, right? You need to know all these radiuses, so we could get in there and do that. In fact, I might ask you to go ahead and do that here. So go to your dimension tool, talk about what that one is, and yeah, I can barely squeeze that in without interrupting this view over here. What that one is, we might also want to know what is the length, right, of the flat right there. And so there's some good dimensions. Let me add one more cool thing. I think we may be able to do it on the detail element over here. We can add a section view, that cut view of something. It's not going to let me do it on a detail, and that's fine. That's pretty normal. I can cut that one in half and drag over. And then, when I zoom in now, I can see the cut actual metal. I could get in there and maybe I will in this case, just really quickly dimension. So go back to the dimension tool, that outer and that inner. And that might be a good place to put on notes that say outer and inner diameters there. So if I clicked on it, I can add a note here that this is the OD. And then this one I'll do what? You guessed it, ID, inner diameter. Okay, and I'm getting a little bunched there, okay? There we go. So at this point, we've got your name, we've got a date. We could give it a title, and so maybe that's what I'll do over here is I'll double click and call it Mr. Field handlebars. Got the overall weight of it, got some good views of it here, some important dimensions, a detailed view, and this ISO view that's shaded. That's it for right now, and I can grade that. See you next time, guys. I hope you enjoyed this video. It's really a joy for me to make these videos for you guys, and I really appreciate the work that you guys put in. So I'm going to try and make some really good videos for the second half of the year to finish this IED course.